Last time we have solved the Schrödinger equation for the second zone, and this is the solution. Now we have to solve the Schrödinger equation for the third zone. But if you can easily understand how to write down the solution in the third zone, because we have already solved the Schrödinger equation in the first zone, and the form of the expression, the form of the equation, the Schrödinger equation is just the same in the third zone, because the potential there is just equal to 0. So in the third zone we have W3 of x, so U3 will be just the same, okay, as before. U3 will be equal to U2 equal to U1, which is equal to e to the minus I e over h bar times time. W3 of x can be written like this. Here we have f, some constant f, e to the I square root of 2m e over h bar squared times x plus g times e to the minus I square root of 2me over h bar squared times x when the energy is positive, f prime e to the square root of 2me over h bar squared times x plus g prime e to the minus the square root of 2me over h bar squared times x when the energy is negative. And also you can have f double prime times x, so f double prime is just a constant, so that's not a derivative, okay? I will call it f double prime just to remind us that we are in the third zone. So I'm using f and g, f prime, g prime, and f double prime here, x plus g double prime here, when the energy is equal to 0. And remember that we will have to consider the first solution here when the energy is positive, whereas we will have to consider the second solution for the second zone here, because we are interested in E less than V0, and we are also interested in the first solution here when the energy is greater than 0 for the first zone. And we have to consider some constraints, right? Because we have to find these constants, okay? We have to find a way to derive an expression for these constants. And we will see that these constants are important because they are also related to, one of them in particular will allow us to calculate the transmission coefficient. And the transmission coefficient will be important to understand how the wave manages to penetrate the barrier with non-zero probability, okay? So what are the constraints that we have to set here? This is the question, and we will answer next time.